The headline number in this Rapidus and Cadence partnership is bold. Design of advanced chips up to twice as fast. But the way I read it, what this news really changes is not speed. It is the way designers work, those long nights spent waiting for a machine to hand back an answer. Read the intent behind the number, and this starts to look like the first step toward a very different daily scene on Japan's chip design floors. Welcome to Semiconductor News Decoded. I'm Ty, with 31 years inside the semiconductor industry, bringing you the real view from the factory floor. In this video, I'll walk you through what Rapidus and Cadence actually announced in their agentic AI partnership, the points professionals are really watching behind that headline of twice as fast, and what comes next for Japan's design floors and engineering talent, all in one sitting. Here's today's news in one picture. Imagine an architectural design firm. We'll lean on this architecture firm analogy all the way through the opening section. This firm takes on the complete blueprints for large buildings. They listen to the client's wishes, settle the overall concept, decide the floor plans, pin down every column and pipe, and finally push the whole package through the legal and safety inspections. Only then is the full set of drawings complete. Here's the tricky part of this job. The requirements slug it out with each other. Widen the windows for better sunlight, and a column gets in the way. Thicken the columns for earthquake resistance, and the rooms shrink. Protect the budget, and the schedule slips. Fix one thing, and something else always breaks, so the architect ends up endlessly repeating the same loop. Tweak the drawings a little, check. Tweak again, check again. On top of that, the inspection calculations take serious time, so the daily rhythm becomes set the job running at night, see the results the next morning. If it fails, fix it and wait for yet another morning. And here's the ironic part. The better the architect, the harder the projects they get handed, and the more of their life gets swallowed by hours spent glued to the desk, waiting for results. Now suppose a team of AI assistants joins the firm, working through the night. While everyone sleeps, they revise and inspect dozens of versions of the drawings, and by morning, they line up their conclusions. Here are the 3 promising plans, and here is the reasoning behind each. The architect can spend the morning on judgment calls, and the overtime spent babysitting the machine starts to fade. From here, let me walk you through what this actually looks like in the real semiconductor industry. On July 17, 2026, Rapidus and Cadence Design Systems, the major U.S. semiconductor design software company, announced a partnership to apply agentic AI to the design of advanced SoCs, meaning the most advanced high-performance chips. Rapidus is the foundry, a contract chip manufacturer, launched to mass-produce cutting-edge semiconductors in Japan. And now that company is bringing AI right to the front door of chip design. The core of the partnership is the integration of RADS, the AI design platform Rapidus is developing, with Cadence's InnoStack AI superagent. The vision is a chain of AI agents working in concert across multiple design stages, from architecture exploration at the very start, through circuit implementation, all the way to sign-off, the final verification before a design ships. 2 new features were announced as well. RAD's Navigator plays the role of a guide, steering designers through the quality assurance procedures. RAD's Indicator plays the role of a warning light, detecting design problems and pointing to countermeasures. In our earlier analogy, it's as if the night shift assistants were given a navigation system to show the way, plus a warning light that flags trouble. What the 2 companies are aiming for is to speed up the design turnaround time of advanced SoCs, the time it takes to get through one full design cycle, by up to 2 times. And Rapidus positions this as part of its AI-native foundry vision, not just applying AI inside the factory, but offering customers an environment where AI supports them from the moment they start designing their chips. Now here's the heart of the matter. The press coverage naturally gravitates to the number, twice as fast. But from my years in this industry, what I believe is most valuable here is not the speed itself. It is that people stop being chained to the tools. Cutting the design schedule in half and changing what a designer's day actually looks like, those 2 things sound similar, but they are completely different. Miss that distinction, and I think you miss what this partnership really means. Take place and route, known as P&R, or timing closure, the stage where you tune the circuit so signals arrive within their time budget. After every tool run, a human has to read through the verification results and decide the next move, which creates enormous amounts of judgment waiting time. If AI agents can handle that analysis and propose the countermeasures automatically, the way designers spend their time changes at the root. Physical design is exactly like our analogy, a brawl between constraints. Tighten the timing and power consumption gets worse. Squeeze the power and voltage drop issues, known as IR problems, raise their head. And you always have to keep an eye on EM, wiring degradation caused by concentrated current. Refereeing this endless brawl, where fixing one side breaks the other, was precisely where a designer showed their skill. And that is exactly why my concern is the hollowing out of experience. When you adopt an AI proposal, and it works, the opportunities to ask yourself why it worked will surely shrink. Engineers who have refereed the constraint brawl with their own hands are, in my view, going to become rarer and rarer. And that experience is precisely the foundation you need to sense when the AI's answer is wrong. Zoom out to the industry map. In EDA, the world of design software, the big three of Synopsys, Cadence, and Siemens EDA are locked in a race over automation levels, much like self-driving cars. How far can chip design go without human hands? Today's partnership means a brand new Japanese foundry has just stepped onto the front line of that race. My read is that Rapidus is after more than efficiency. Rather than staying a company that only takes on manufacturing, it wants to welcome customers into its own environment from the very entrance, the design stage. If design and manufacturing can be woven together with AI, then even a latecomer can build deep, sticky relationships with customers. That, I believe, is the bet they are making. And in the end, what decides everything is people. AI makes mistakes. Just as self-driving still comes down to the driver who can grab the wheel at the critical moment, the question is whether you can keep people on the floor who feel that something is off in the verification results and can say, this proposal is wrong. Beyond the automation level race, I believe that is where winners and losers will be decided. Let's think about the impact on Japan. For Rapidus, being able to build customer touchpoints at the design entrance without waiting for mass production to ramp up is a major opportunity. For design companies in Japan, it could be a tailwind too. It widens the doorway for companies that had given up on advanced chips because they simply could not staff the design talent. At the same time, Japan's design floors are being handed homework. In an AI-first design flow, the value of being a hands-on operator goes down, and the value of judgment, evaluating the AI's proposals and spotting its mistakes, goes up. How do we let young engineers build up that experience of refereeing the brawl? I believe the real test is the blueprint for developing people. Let me wrap up. Rapidus and Cadence announced a partnership to use agentic AI to speed up advanced SoC design by up to 2 times. But the real value lies less in the speed itself and more in freeing people from being chained to judgment waiting. And the next battleground is whether we can keep engineers who can spot the AI's mistakes. That is the lens I'll be using as I follow this story. That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.